Hello my dear students, welcome back. My name is Rahul and in this video I am going to discuss the reaction of alcohols with Grignard reagent. That is reaction with Grignard reagent. Well, when we talk about the Grignard reagent we can represent as R Mg X. Okay, and the noticing point is here that magnesium is metal and it is electropositive, and because of that it gains a positive charge and it have tendency to give away the electron density towards the alkyl group, and compared to the magnesium the carbon is more electro here and therefore it gains a negative charge. So whenever the bond breaks here, the carbon takes its bonding electrons and migrate to electron deficient species. Take a look at the alcohols. We can represent the alcohols as R, O, H. Alcohols are acidic in nature. They can easily give the H plus ions. And we have a Grignard reagent, that is R, Mg, X. Now in this case what happens? The proton furnished by the alcohol get react with the alkyl group and we get a product that is R, H plus RO Mg X. So this is called as alkoxy. This is alkoxy magnesium halide. We take one general example. Take example of CH3OH, methanol. So methanol is reacting with the ethyl magnesium bromide, that is plus C2H5 Mg Br. Now reaction proceeds, that should be in the presence of dry ether, and we get a product that is CH3, CH2. This is a CH3, CH2 are going to write like this, and to this the hydrogen get attached. This is how the reaction takes place. We get here C2H6 we get. Along with that we get here CH3O Mg Br, methoxy magnesium bromide we get. So here ethyl group is there, that is converting into ethane. We get ethane here. We'll see the mechanism how the reaction takes place. Now I will take a general example, that is C2H5OH. And now here I'm going to take some general terms like R, Mg, X. So now what happens here? This R is negatively charged and Mg is positively charged, and here this R take its bonding electrons and get migrate towards this proton. At the same time, the bonding electrons exist between the oxygen and hydrogen get migrate towards this oxygen, and we get a product. The reaction should be carried out in dry ether and we get C2H5O minus, and that O minus is interacting with the Mgx, that is Mg X we get. Along with that, this R is interacting with this proton. It means that we get a product that is RH. We get here alkane, and here we get that is ethoxy magnesium halide. In these reactions, the order of reactivity, it depends upon the degree. That is, the primary alcohols are more reactive than a secondary alcohols, and secondary alcohols are more reactive than a tertiary alcohols. The reason is the acidity. Stronger the acid, greater the reactivity. Next reaction, that is Easternification. This is a very important reaction. in this reaction we are taking the alcohol and that is reacting with the carboxylic acids. Even we have various methods to prepare the esters, but we will discuss here alcohol reacting with the carboxylic acids. So first I will list that how we can get here esters. When alcohols, if they are reacting with carboxylic acids, or it may react with the acid halides, second one, acid halides, or it may react with the acid anhydrides. So there are various methods are there by that we can prepare the esters. So take an example here. We have here R dash OH, and that is reacting with the carboxylic acid, that is R C double bond O OH, and here we get a reversible reaction here, and the product is R C double bond O O R dash, and along with that we get here water molecule H2O. So this water molecule can interfere in a reaction with the ester, and when the esters are hydrolyzed, it giving back the product, that is alcohol and carboxylic acid, and therefore this water molecule should be removed. This can be removed using the sulfuric acid. This is removed by H2SO4 to increase the forward reaction. Okay. Then we take one more example that I have here, R dash OH, and this is allowed to react with the acid chlorides or acid halides, that I will take here R C double bond O Cl. So now the again reaction process in a forward direction. So in this case, product is, we get R C double bond O, and here we get OR dash. Along with that we get a product here, that is HCl. So again this HCl interfere the reaction with the ester and going back to the that is reactant side, and therefore removal of this HCl is very important, and to remove that we use here the pyridine. Okay, we use here pyridine. Basically it is a base. Pyridine is a base, and when you add a pyridine, it remove the HCl, that increase the rate of forward reaction. That increase a rate of forward reaction. Both are the same meanings here. Let's go for the another example, that is we have R dash OH, and that is reacting with the next, that is anhydrides, acid anhydrides, like R C double bond O, then here is C double bond O R. These are called as the acid anhydrides. So the reaction proceeds and we get the product, that is R C double bond O, and here we get O R dash, and along with that we get some byproduct, that is R C double bond O OH. Okay, so this is very vigorous reaction. As soon as you add alcohol to the anhydrides, the forward reaction takes place. There is no backward reaction. This is a good method actually, and this reaction I can mention here, this is very vigorous reaction. Vigorous means it is very rapid reaction. Okay, let's understand that the mechanism of this reaction. I have here the mechanism with the carboxylic acid. So I will write the first carboxylic acid. that is R C double bond O OH. The oxygen having a lone pair of electrons, and here also oxygen having a pair of electrons. Now I have alcohol, that is O R. This oxygen also having a lone pair of electrons here, particular 2, this is H. Now you know that in the beginning only I will explain that this oxygen is electronegative atom, therefore it withdraws the electron density from the carbon and gains here small negative charge. In the same way, this carbon loses electron density and gains here a small positive charge. Now this carbon is electron deficient, and therefore the oxygen from the alcohol donates the electron pair to the electron deficient carbon. At the same time, oxygen withdraws its bonding electrons, that particular pi electrons, and we get the product, that is R C. This should be O minus, and here one OH is attached, OH, and then it is connected with O. Here is one hydrogen. The same thing I'm writing. Better I will use here some other colors. You can differentiate the molecules. This should be the oxygen, and here is one hydrogen, and here is R. So out of the two pair of electrons, one pair of electron is used for the bonding between carbon and oxygen, and one is left as it is. The one pair is lost, therefore it is a plus sign. Now you can see that this oxygen is electron deficient right now. It want to break any of the bond out of 3 bonds. So therefore, at the same time, here is one oxygen is that this oxygen actually electron rich, and therefore it will take this proton. At the same time, whatever the bonding electrons are there between oxygen and hydrogen get migrate towards the oxygen. Migrate towards this oxygen. Okay, and then we get the next product. So here I'm going to write, that is R C. This should be the OH now. Again here one more oxygen and hydrogen is there, and now here this side we have oxygen and R, and along with that is the oxygen having 2 pair of electrons. Now looking at this molecule, looks like it is stable, but carefully observing, this carbon is holding 3 electronegative atoms, that is oxygen, 1 2 3, and because of that it is unstable. So to overcome this, the one of the OH group should be eliminated out, and to eliminate that, here this bonding electrons are there now between oxygen and hydrogen, they get migrate between the oxygen and carbon. At the same time, this OH get eliminated at OH minus, and that OH minus and this H combine and form water. Here is reaction, minus H2 I going to write first, and remaining part I going to write here, that is R C double bond O. This is a double bond O we get here, and next we have here O. Okay, but I will write the yellow color, O, and this is R. These are the 2 pair of electrons on the oxygen. Just carefully observe few points regarding this mechanism. That is, first thing, you can see that the reaction of alcohol with the acid, in that this carboxylic acid do not give the H plus ions. Instead of that, alcohol give the H plus ions. Okay, and whatever the oxygen is there in this OR group is there, this is from the alcohol part. You just notice that. Okay, so same thing we can write the mechanism with respect to acid chlorides and acid anhydrides.